So now after taking the inverse Laplace transform, we get h of t is equivalent to summation I is equal to 1 to capital N ai e raised to minus pi t u of t. We will expand this again, that is a1 e raised to minus p1 t u of t plus a2 e raised to minus p2 t u of t plus it tends to a capital N e raised to minus p and t u of t. Now u of t, as we can say, it is a continuous time unit step function. Let t be the sampling period and h of n be the impulse response of digital filter. Now the impulse response of the digital filter is obtained by uniformly sampling the impulse response of analog filter. So let us see how it works. That is, therefore h of n is equal to h of t when small t is equal to n multiplied by capital T. That will give us h of n and t. So therefore h of n can be replaced from the equation or by replacing t by n into t. So h of n is equal to h of t where t is equal to nt. So it will give us h of nt, and again summation I is equal to 1 to capital N a I e raised to minus pi nt, as t is replaced by n into t and u of n into capital T. Now again we will expand this term, that is a1 e raised to minus p1 nt u of nt plus a2 e raised to minus p2 nt u of nt, and finally a n e raised to minus p nt u of nt. Now on taking the z transform, we will get the equation such as h of z is equal to z transform of h of n. But first let us define what is z transform of e raised to minus a and t terms. So it will be like e raised to minus a and t u of nt, that will be given as 1 upon 1 minus e raised to minus capital A t and z raised to minus 1. So taking the z transform of h of n will give, using the same formula, a1 into 1 upon 1 minus e raised to minus p1 t z minus 1, that is z raised to minus 1, plus a2 into 1 upon 1 minus e raised to minus p2 t into z raised to minus 1 plus, and it goes on to an 1 upon 1 minus e raised to minus p and t z minus 1. So it comes out to be summation I is equal to 1 to capital N ai 1 upon 1 minus e raised to minus p I t z raised to minus 1. Now if you compare the expression of h of s and h of z, we will see that 1 upon s plus p1, that is will be transformed to 1 upon 1 minus e raised to minus p I t or 1t z raised to minus 1. So this is used or done by impulse variant transformation, where t is the sampling period. This equation also shows how the poles from analog domain are transferred into digital domain. This transformation of poles is also called as mapping of poles. Thank you.